Nuela, help me to remind this, okay?
Okay, Professor.
Please, I appreciate so much. Okay, the PowerPoint I created for this lecture, quadrantal, look at that. Look at the quadrantal, wow, make it zoom. And this, we have more information. We have sine, cosine, tangent, cotangent, secant, and cosecant of the quadrantal angle. 0, 90, 180, 270, and 360. Guys, this is yours. I sent to you and you're using every day if you want. You, little by little, my intention is you memorize somehow. Entonces, for example, sine, 0 degree. Sine es 0, cosine es 1. And tangent, bueno, no, in the unit circle you don't see tangent. But you know que tangent, any angle is equal to sine divided by cosine. And the 0 degree, so you want to find tangent 0 degree, is sine 0 degree divided by cosine 0 degree. Sine 0 degree is 0 divided by cosine 0 degree is 1, and 0 divided by 1 is 0. That is the reason que tangent is 0. And cotangent, que es the reciprocal of tangent, is 1 over tangent. So we're using this identity. Remember the reciprocal identity and the sine, tangent, cotangent identity, and Pythagorean identity. Entonces, 1 divided by 0 is undefined. Because you know that division by 0 is impossible, no? This is clear. This is the reason it's undefined. Secant. Cosine is 1. 1 over 1 is 1. Look at that. And cosecant, 0, is reciprocal of sine. Is sine 0, I know que 0, 1 over 0, again is undefined. That is the reason in the quadrantal angle somehow happen que the trigonometric function is undefined. Okay? So now this is the idea. Super easy. Super easy, right? Entonces, my intention is little by little present the information. You try to understand, you try to visualize, and after little by little, my intention que you memorize. Because when you take calculus, the teacher of the calculus suppose that you know by memory this idea. Or suppose that you know memorize everything, but you can using the piece of paper, si I know que the sine is 0 and entonces now the tangent is 0 divided by 1 is 0, no? You deduct, you derivate. Okay. In the another quadrant, because we focus the explanation only in the first quadrant. I want to extending everything to the second quadrant, third quadrant, and fourth quadrant. This is the complicated part. Okay. Animation. Okay. Now switching to animation. This is animation. Okay. Do you see again the animation? Do you see again the animation?
Yes, Professor.
Yes.
Okay, listen to me. Pay attention. Now I want to investigate what happened in the other quadrant. You know, this is the first quadrant. You see how I move the mouse and the screen or no?
Yes.
This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Okay, the first quadrant is when the x and y are positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both are negative. In the fourth quadrant, x is positive but y is negative. So this change completely, not the value of the trigonometric function, change the sign. And I need to memorize, I need to understand the mnemonic device to remember this. Let me see. Continue again. 0 degree. Cosine 0 es 1. Sine 0 es 0. 30 degree. Cosine 30 degree, radical 2 over 2, and sine 30 degree, 1/2. Pero positive, both. 45 degree, radical 2, radical 2. Cosine, radical 2, sine, radical 2. Ese es 45 degree, pi over 4, en radian. And pi over 3, que es 60 degree, cosine es 1/2, and sine is radical 3 over 2. Now, one quadrantal, 90 degree, cosine 0, sine 1. Let's move on to the next. This is a common angle that we can compute without calculator. Another angle, you have no table, and the only possibility is using the calculator, no? Pero no. In the moment is without calculator. So far. So the common angle is, what's the next guy? Now again, for the unit circle, the next guy is this guy. Oh, 2 pi over 3. 2 pi over 3 is 120 degree. And the cosine is negative 1/2, and sine is positive radical 3 over 2. Interpretation this. Do you see que the adjacent is negative? Because it's in the left direction of the x-axis. That is the reason que es negative. So any angle in the second quadrant, the cosine is negative. However, the sine, que es the red segment, is positive. Let's move on to the 135 degree, que es this guy, 3 pi over 4. I put in radian, guy, to, you know, porque es easy to memorize in degree, but you need to memorize in both, in degree and radian. 3 pi over 4 is 135 degree. Look, you see here. Don't care the decimal part, because I move a little bit. Entonces, cosine is negative radical 2 over 2. You know que es the same value, but the only thing that change is the sign. Cosine negative, sine positive. What is the next guy? The next guy is, boom, this guy. This guy is 5 pi over 6, que es 150 degree. The cosine is negative radical 3 over 2, and the sine is positive, 1/2. Now one quadrantal, que es 180 degree, negative 1,0. The cosine is negative 1 and sine is 0. Let's move on to the third. So the conclusion of the second quadrant is cosine negative, sine positive. Yes or no? Do you see geometrically that the blue is negative and the red is positive?
Yes, Professor.
Super. Complete the situation, different happen in the third quadrant. Boom. In this case, both are negative. The blue is negative and the red is negative because point down on the y-axis. So this angle is 7 pi over 6, que es 210 degree. 210 degree. The cosine is negative radical 3 over 2, and the sine is negative 1. Okay, remember the first component is cosine, and the second component is sine. Next, 5 pi over 4. 5 pi over 4 is 245 degree. 245 degree. Entonces, both are negative. Sine and sine is the same value because it's isosceles triangle. Look, 225 degree. 225, not 45. I make a mistake. 225 is negative radical 2 over 2 and negative radical 2 over 2. Here, 4 pi over 3 is 240 degree. The cosine is negative 1/2, and the sine is negative radical 3 over 2. Another quadrantal angle is 270 degree. Cosine 0, sine negative 1. Okay, entonces in conclusion, in the third quadrant, everything is negative. Sine and cosine are negative. Makes sense, right? Because the blue segment que represent the cosine, sorry, is in the negative direction, and the red one is also in the negative direction of the y-axis. Okay, then in the fourth quadrant, let's move on to the fourth quadrant. The first angle we can find is this guy. Ooh, 300 degrees. 300 degrees in radian is 5 pi over 3, and the cosine is positive. Look, in this case, the blue segment is positive. However, the red is negative. The sine 300 degrees is negative radical 3 over 2. Okay, let's continue. 315. 315, que in radian is 7 pi over 4. The cosine is radical 2 over 2, and the sine is negative radical 2. So always in the fourth quadrant, the cosine is positive, and the sine is negative. Okay. And finally, no. Here, this is 11 pi over 6, que is 330 degrees. The cosine is radical 3 over 2, and the sine is negative 1/2. So the cosine, sorry, is positive, que represent the blue segment, radical 3 over 2, comma, and the sine is negative, represent the red segment. And we come back again to the 0 degree or 360 degree, que es the same. Let me summarize this idea in the whiteboard. Okay, important information. Let's come back to the whiteboard. Do you see that? You want to see another thing, or it's clear the animation?
It is. But I have a question.
Wait. I don't finish. When I finish, you have a question. Okay?
Okay.
Let me come back to the whiteboard, please. In the whiteboard, I try to condense this information in one mnemonic super fantastic device. Okay, do you see the whiteboard?
Yes.
Let me erase everything. Okay. So then we have four quadrants. Look, this is my rectangular coordinate system. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Okay? So I discovered in the first quadrant, all trigonometric functions are positive. All. Sine, cosine, tangent, all. However, I discovered that in the second quadrant, only is positive sine and the family of sine, que es cosecant. It's the only guy that is positive. The rest is negative. In the third quadrant, sine and cosine are negative. We discovered that. However, the tangent, que es the division, si both are negative divided by negative is positive. So the tangent and the cotangent are positive. The rest, no. The rest are negative. In the fourth quadrant, the only guy that is positive is cosine and his family, que es secant. Okay? Entonces, how you memorize this information? Bueno, the mnemonic device que the student create for this is all students take calculus. This is the international mnemonic device. All mean in the first quadrant, all trigonometric functions are positive. A student is a mnemonic device que you memorize the first letter, S, que es sine. Sine and his family, que es cosecant. Take T, tangent, and cotangent in the third quadrant. This is the first quadrant. This is the second quadrant. So basically, this phrase contains four words. Third quadrant. And the fourth quadrant, calculus, que es cosine. Okay, so I want to explain, so you understand this. I want to explain what is the another mnemonic device that you need to know, because the number is the same. The only thing that you need to adjust the sign. O sea, it's the same value, radical 3 over 2, or radical 2 over 2, or 1/2. It's a repetition, the same cyclical number, but the only thing that changed is the size. Noela, your question.
It's clear, Professor. It's clear.
I know. No. I know it's not 100% clear. It's not 100% clear. I want to explain more to clarify this idea. Okay, now, you copy that?
Yes, I did.
Okay, I can erase?
Yes, you can.
Now, let's move on to the PowerPoint again. Okay, I want to say when the class is over, guys. PowerPoint. Here, PowerPoint. Trigonometric tables is the name. Look, I want to copy this. Okay, this is the collection, the complete collection. This is the first quadrant, look. This is the first quadrant. That part is the first quadrant. First quadrant. This is the quadrantal, 90 degree. This is the second quadrant. This is 180, que is the border que divide the quadrant. This is the third quadrant. And this is the fourth quadrant. And you see that the number is the same. The only thing that changed is the sign. The sign. And you adjust the sign. Ahora, okay, what is the idea? Well, the idea is, okay, to complement this idea, you memorize this stupid thing. No. The only thing you memorize is the first quadrant. And not the first quadrant completely, only this column. I know that this column is completely Bauer. I know that this and this is Bauer, no? This and this is Bauer. Because I put it in different order. Okay, so now what is the idea? Well, we're using one thing que is a reference angle. So suppose after we see a complicated example in which I give you arbitrary angle, bam, and you need to find the all trigonometric function or a specific trigonometric function. To say you don't know, and to say you find the reference angle. Let me explain the idea for the reference angle. Reference, this is F, angle. Reference angle is our friend. Que help me to understand this complicated table. So what is the idea? Well, see, the angle is in the first quadrant. I call reference angle alpha. And theta is the given angle. So I give you one theta, and you find one friend, que es called a reference angle. Entonces we have in the different quadrant, no? In the first quadrant, in the second quadrant, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Bueno, si the angle is in the first quadrant, si theta lie in the first quadrant, theta is equal alpha, it's the same. So you don't need to do anything. You don't need to do anything. However, si theta lie in the second quadrant, like that, you find the reference angle. What is the reference angle by definition? It's one angle que have in between the terminal side and the x-axis. In other words, this guy. This is alpha. And alpha is always acute, and alpha is always less than 90 degrees. So you, to find the trigonometric function of theta, you try to find the same number of the alpha, and you adjust the sign. Okay, the idea is clear. The idea is, number one, find the reference angle, que es alpha. Find the value of the trigonometric function, que you know in the first quadrant. And you adjust the sign according to the sine of the trigonometric function in the specific quadrant. Okay, I promise I bring 2,000 examples of this today. Okay, but let me finish the idea for the reference angle. Reference angle is my friend que help me to discover the sine and the value of any trigonometric function in any quadrant. Look, suppose now I have one angle in the third quadrant. This is my theta now, que lie in the third quadrant. What is my reference angle? This is my reference angle, alpha. Always acute in between the terminal sine and the x-axis. And the fourth quadrant. Well, in the fourth quadrant, suppose I have one angle in the fourth quadrant. This is theta. And this is alpha. Here. Okay. Entonces, what is the formula? Bueno, the formula is, bueno, alpha is equal to theta. It's obvious, right? In this case. In this case, no. Alpha is theta minus 180. Okay, because 180 is this angle. Entonces, theta minus 180. Give me, or 180 minus theta, much better, no? Sorry. 180 minus theta is alpha. In the other quadrant, alpha is equal theta minus 180. It's a formula for finding the reference angle in the third quadrant. A formula for finding the reference angle in the second quadrant. And the formula, no, we have no formula because it's the same. They are the same, twin brother. And the fourth quadrant, bueno, alpha is 360, que es the entire revolution, minus theta. It's a formula for finding, if you want to express it in positive direction, o sea, counterclockwise. You want to express it in negative direction, que is also possible. Alpha is negative theta. So in the fourth quadrant, we have two formulas. Either way, if you prefer positive direction, 360 minus theta, or you prefer negative direction, it's negative 60, negative theta. So this is a formula for finding the reference angle. And reference angle help me to find any value of the trigonometric function. Okay. We are ready? No, we are not ready. We need more information. Look. Well, no, let's do an elementary example. Look, suppose that I need to compute a sine 135 degrees. Y suppose que I have not this table. Entonces, I know que 135 lie in the second quadrant. Yes or no? Because this is the angle between 90 and 180, second quadrant. Entonces, I find alpha, que es 180 degree minus 135, es 45 degree. Entonces, you find the sine of 45 degree, que es the sine of the reference angle, que es radical 2 over 2. I know by memory this. In the first quadrant, I know by memory. In the second quadrant, no. In the third quadrant, no. In the fourth quadrant, no. But in the first quadrant, yes, I memorized the first column. You adjust the sign. Yeah, I know que all students take calculus. Si we are in the second quadrant, get here, I know the sign is positive. And the final answer is radical 2 over 2. And let me check in here, just in case. Sine 135 degrees. Look at that here. Radical 2 over 2 positive. Do you see? This is the idea. Without calculator, by hand, only memorize the angle, the trigonometric function of the first quadrant. Okay? Okay. I have more example. We have 1,000 examples today, but this is the idea. Suppose I want to complicate a little bit now. Let me know, guys, if you understand or not so far.
I did, Professor.
Okay,
We
okay.
did some quiz easy.
Es easy. Es our friend que help me to understand this. Suppose. Sine. Another example. 600 degrees. Wow. It's too much. It's too much. 600 degrees is too much. Is 600 degrees is greater than 360 degrees, que es 1 revolution. So I suppose que you need to, this angle is 1 more than revolution. Entonces you subtracting 600 minus 360. You subtracting 600 minus 360. It's 240. Ah, nice. Entonces this is a co-terminal angle. So we're using the same idea. Wow, I am mixing every concept now. Co-terminal, que we studied the first lecture, and reference angle, que we studied today. Entonces, this I know que es equivalent, no equal, same 240. Right? And 240 lie in the third quadrant. 240. No, exactly like that. Like that. 240. But I have no idea. I don't remember 240. But I remember the reference angle. The reference angle, the formula is you find this. Not necessarily memorize the stupid formula. This is the reference angle. This is alpha. And alpha is 240 minus 180. Que es 60. Entonces I know very well que sine 240 is equal somehow sine 60. Sine 60, I know que es 1/2. Sorry, radical 3 over 2. Radical 3 over 2. However, sine 60 is not equal sine 240 because the only difference is the sign. And the sign in the third quadrant is negative. So my famous final answer is sine 600 degrees is negative radical 3 over 2. Repeat again. You have an angle. You have an angle. 600. Okay, I have no idea. No, I am lost. You see that 600 is bigger than 360 degrees. That means actually our angle are doing more than 1 revolution. Look, actually my angle is like that. 1 revolution, que es 360, continue, and stop in 240. How do you know that? You subtracting 360. See, this new answer is bigger than 360. You continue subtracting minus 360, minus 360, minus 360 several times until you get one answer que es less than 360. And you determine exactly what is the angle, the coterminal angle. So now when you have 240, sine 600 is equal to sine 240. Pero 240, I don't remember. I remember 60, 30, and 45 only. I am lost 240. You find the reference angle. The reference angle is 60 degrees. So I know very well que sine 60 degrees and sine es radical 3 over 2. And you adjust the sign. I know que in the third quadrant, que es when the original lie, my triangle is the sign is negative, and the answer is negative. Negative, 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 radical 3 over 2. Do you see that? Okay. One more important property to complement this idea is the even, okay, let me try to show you here in the PDF. Okay, we come back, guys, to Wait a second. Here, over there. Trigonometric. No. Okay. Okay, there you go. Let me go to the desktop. Class, trigonometric. Chichi. Do you remember the famous Chichi, right? Let me see, in this page. Yeah, in this page, I guess so. This page. Okay. Okay. I want to discussing with you another complementary idea. Guys, this is very, very complicated, but it's easy when you integrate everything in your mind. Look, we focus in this identity. Wow. Okay, let's focus in this even odd formulas and periodic formulas. Let me discuss in first even, que es super easy. Look, the sine function is odd function. So when you change theta for negative theta, this negative inside the parenthesis is also outside the parenthesis. This is a typical odd function. So don't be scared when you see sine negative 30 degree, because it's a negative sine 30 degree. So you put this negative inside the parenthesis, outside the parenthesis. Don't be scared, because sine is odd function, and also is odd function tangent. Odd. And of course, the same family, cosecant and cotangent. Eso. However, cosine is even function. It's even. Therefore, si you try to find cosine negative 30 degree, it's positive cosine 30 degree. And disappear the negative. So don't be scared. When I see in the problem, put negative, positive, negative. Oh, I don't understand, professor. No. You apply that property. Okay, that property is the even odd property. So the negative, when it's sine, you put outside. When it's tangent, you put outside. When this cosine disappear because it's even function. Clear? This is another complementary idea. And the periodic is easy or relatively easy. Let me show you. Okay, in order to find the coterminal angle in the trigonometric function, you subtracting 360 degree. 360 degree, que es 1 revolution, o en radian es 2 pi. Entonces now, the coterminal is 2 pi m, o sea, sine, let me try to translate this, theta plus 2 pi m is equal sine theta. So basically, suppose you're given this horrible angle that you don't know. So si you remove that part, how you remove that part? Subtracting 360. The reason is m, because you need to subtract it 1 time, 2 times, 3 times, until you get one angle that is less than 360 degrees. And this is valid for sine and cosine. And cosecant and secant, que is the family. En tangent, no. En tangent, the periodic property say theta plus pi m. Okay, entonces es no 360, es 180, because the repetition, the periodic is a repetition of the tangent and cotangent is 180. So when you face one problem, que es the tangent, you don't need to subtracting 360, you subtracting 180. Okay, subtracting 180 several times until you get one acceptable angle, and that's it. Okay, let's move on to the example and integrate everything. Integrate everything. Integrate what? Coterminal, reference angle, periodic property, and even odd property together. Suppose, example 1. Compute sine 900 degrees. Well, 900 degree is greater than 360. So you subtract 900 minus 360 is 540. 540 is still greater than 360. 540 minus 360 is 180. So actually, I know that this is equivalent, say, sine 180. And sine 180 is quadrantal. And sine 180 is 0. And the answer is 0. End of story. Do you see that?
Yes,
Yes,
Professor.
Professor.
I have a question.
Go ahead.
Yes, Professor.
Yes,
Professor,
Professor.
we're gonna
We're gonna
select the
select the
sign.
sign.
Say again.
So, Professor,
I'm
I'm wondering,
wondering
we're gonna
where
see the
to see the
sign
sign
because I cannot
because I cannot
see
see
how we can find it.
I know, okay. You need to know a memory. Okay, for 180 here, que es quadrantal. You know que sine is 0, no? Sine 180 is 0. And cosine 180 is -1. Yes or no? Do you see before, no?
Yes, Professor. Do I need to memorize? So
No, a little bit. I try to memorize, but not too much. I memorize the most important. I memorize 30 degree, 45 degree, 60 degree, and the quadrantal. 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree, que is equivalent to 0. That's it.
okay, thank you, Professor.
Okay. Let's move on to another. Cosine. Negative 1,350 degree. Wow, what the hell is that? Entonces you see, wow, I scared. No, because I know the property even odd. I know que cosine function is even function, therefore it's cosine 1,350 degree. So you remove mentally the negative sign. No important. No important. No important. Now 1,350 is bigger than 360. You subtracting 360, que es the periodic, and the cosine. I did that. 990 degree. And we continue 990 degree minus 360 is 630. And 630 still is greater than 360. So 630 minus 360 again. How many times? Well, n times. 3 times I subtracting. I don't know. It's 270. Okay, and 270 stop. Entonces, this is equivalent cosine 270, que es cuadrantal. Y ahí no que cosine 270 es 0. Okay, you need to memorize only 30, 45, 60, 90, 0, 180, 270, and 360. Okay? Everyone follow me. Go ahead. Everyone follow me. Go ahead.
I was just going to ask for you to zoom out so I could take a picture of it, of the notes, example
okay.
1, 2. Thank you.
Okay, we move on to another example. Suppose now, example 3. Okay, suppose I need to compute cosecant negative cosecant negative 1,680 degree. Okay, wow. Entonces I match in my mind que cosecant is family of the sine. Yeah, I know by memory que sine is odd function, therefore it's equal the minus cosecant 1 1,680 degrees. Okay? Because sine and cosecant is family, and tangent and cotangent is odd function. La only gets even is cosine and sec. It's even. When it's even, disappear the negative. When it's odd, no, I put it outside. That's it. That's it. Y I know que 1,680 degrees is greater than 360, entonces yo subtract the 360, no? Because the periodic que I subtracting is 360. So put in the calculator, it's 1,320 degrees. Continue subtracting in order to find the coterminal. Because there's one revolution, two revolution, three revolution, 600 degree, 600 degree minus 360. You subtracting always 360, one in sine and cosine. And tangent, cotangent, you can subtracting 180, que es the periodic. In this case, no. It's 240. Ooh, 240. 240. 240, stop here. Because 240 is smaller than 360. Okay, so now, this is, so far, we focus in 240. 240 lie in the third quadrant. 240. And you find the reference angle. The reference angle is this angle. Okay, this angle is 240 minus 180, que is 60. And the reference alpha is 60. So basically, I need to compute the cosecant 60 degrees. And cosecant 60 degrees, I have no idea. I am lost because I memorize only sine and cosine. The only I using the identity. I know que es the reciprocal of sine. And sine 60 degrees, I know que es by memory radical 3 over 2. Entonces 2 radical 3, rationalize, radical 3, radical 3. Entonces cosecant 60 degrees is 2 radical 3 over 3. And this is a crucial moment in which you adjust the sign, because actually this cosecant, cosecant 240, remember our original data is 240, no? However, my alpha, que es my friend, que help me to understand, is 60 degrees, que es the reference angle, es negative. Es negative what? Negative 2 radical 3 over 3. But remember, at the beginning, we discovered this idea. So we have another negative here. This negative is 240, but we have a negative because remember, the supposition at the beginning is negative angle. So this negative angle rotate clockwise. I don't know exactly where it's located, but I know using the even odd property que es negative. So we have double negative, and negative together is positive. And the answer is 2 radical 3 over 2. Boom. Final answer.
Professor, can I ask you a question?
Go ahead.
The thing that I didn't understand, Professor, is like, for example, the last part, it was negative, right? Because of the property or because it's located on the third quadrant?
Excellent. This is the idea. Remember, 240. Any trigonometric function of the 240, I compute the same trigonometric function of the 60 degree. But 60 degree is the reference angle, and the angle, the sign of the corresponding trigonometric function is positive because everything is positive in the first quadrant. And you adjust the sign nulla now. I know we are in the third quadrant, y I know que the only guy que es positive in the third quadrant is tangent and cotangent, and cosecant is negative. Right?
Right, Professor.
And don't forget the first part, que we transform a little bit negative angle to positive angle using the even odd property. So we have double negative, and double negative become positive. Make sense?
Yes, it does. Thank you.
Okay. Entonces, you understand a little bit, no? A little bit. One more of the degree, and we start with the radian. One more of this. I want to erase the ball guy. Clear. Okay. This is secant. Compute secant. 2700 degree. Wow. Okay. I know que es greater than 360. Entonces I need to find the coterminal angle. 2700 minus 360. Two 2,340. 2,340 degree minus 360. This is the periodic. Minus 360. 1,980 degree. Minus 360. 1,620 degree. It's easy, no? I do a calculator. Minus 360. There's 1,260 degree. $900. Wow. Little by little, you decreasing. So actually, we are doing 1 revolution, 2 revolution, 3 revolution, 4 revolution, 5 revolution. Wow. Now 900 minus 360. 540. 540 minus 360. 180. And you stop here because we are doing 1, 2, 3, 4, 5, 6, 7 revolution. Entonces, the coterminal angle of the 2700 is 180 degree. And this is equivalent to say secant 180 degree. 180 degree is quadrantal. Entonces it's easy to memorize. Well, little by little you memorize this. But I have no idea secant. Secant is completely, I never remember this. I don't need because I know que es the reciprocal cosine. Entonces en the quadrantal 0, 90, 180, and 270. 180 here. And 180, the point is negative 1,0. O sea, cosine. In other words, cosine 180 is negative 1. 1 over negative 1 is negative 1. The answer is negative 1. Boom. After, so actually my angle is, look, it's crazy. It's 1 revolution, 2 revolution, 3 revolution, 4 revolution, 5 revolution, 6 revolution, and the 7 revolution, stop here in 180. You get the idea?
Hi, Professor.
Go ahead.
I'm here, Jose Alegre.
Hey, Jose Alegre.
Yeah.
Bueno, entonces, we spend the rest of the time, guys. I want to introduce you to Jose Alegre. Jose Alegre is, let me come back to, okay, Jose Alegre is the tutor que es assigned in our class. Entonces, Jose Alegre want to talk to you. Explain the schedule, what is the plan, what is the group. Come on, Jose.
Okay.